Welcome to the Rolf Glass project video. Rolf Glass is a U.S. glass decorating manufacturer located in Mount Pleasant, Pennsylvania, and they are known for cutting unique designs on high-quality glassware. Founded in 1981, they specialize in cutting, polishing, and sandblasting glassware. This is the cutting area at Rolf Glass, and this is what our project focuses on. Cutting is 90% of their production and is the biggest bottleneck. So our project addresses the fact that Rolf Glass is struggling to keep up with the 10% yearly increase in demand. The problem statement for our project is Rolf Glass is expected to have significantly increased demand in the future. With current cutting process production, they will not be able to meet this demand. The objective for our project is to develop a strategy encompassing employees, machines, and technology to help Rolf Glass satisfy this expected increase in future demand. Some of the methodology that we used for our project includes a detailed process flow of the cutting operation, a fishbone diagram, which allowed us to determine some underlying causes of lack of production. We decided to implement a PLC that will track machine utilization. We summarized all of their yearly setup and cycle times for the cutting processes, put together a standard unit of production, which allowed us to then determine a standard production volume, and then we used this standard unit to do a forecast analysis, which allowed us to quantify future needs and requirements. Finally, we proposed a strategy and recommendation to Rolf Glass. As aforementioned, the deliverable will be a strategy with a detailed project plan that needs to be taken to satisfy future demand. This will include a PLC program, along with a next steps analysis, which includes a database to organize all of the data, and an HMI, which is a human-machine interface, and then also our detailed analysis and recommendations depicting methods to increase production capacity. We are aiming to increase efficiency, reallocate human resources, and boost their employee incentive program to increase production. This is a high-level process flow that allows us to single out the cutting process as the main problem. The first step is order entry. Rolf Glass receives orders, usually online or through email. Then it gets sent to scheduling. They have to determine whether it's a Rolf Glass job or a service job, and then once it's scheduled, it's sent into production. There's the cutting process, the polishing process, and then it gets packaged and sent to shipping. Within the cutting process, there are 7 machines. 5 of them have 8 heads, and 2 of them have 4 heads. These machines run 24 hours a day, 5 days a week. This is a fishbone diagram of the cutting operation, which allowed us to determine some of the problems that Rolf Glass has. Specifically, I want to note that they have a lack of setup manuals and standardized processes. They have a need for machine tracking to standardize production, and better production planning and better forecasting will allow them to increase their capacity.
After our analysis of all the problem areas in the cutting process, our first plan of action was to implement a PLC into the cutting machines. This stands for a Programmable Logic Controller, and it is used to track the machine data. The main focus areas of this machine data would be the cycle time. This is the time that it takes for each cycle to run the glassware, the downtime, what the employees are doing when the machine is down, and the number of heads in use. The reasons for tracking the machine data would be to accurately track when the machine is being utilized instead of relying on their manual production sheets, and this reduces the ability for false data to be logged on these manual production sheets. The machine downtimes for the breakages can be accurately represented, and the data can be organized into a database, which will increase organization. The following shows the program we made to be set up with the PLC. It utilizes ladder logic, so we can set up the timers for the cycle time when the wheels are being redressed and when the vacuum is being drained, and it will also indicate which of the heads, whether it be 4 or 8, are running. The following video shows a short demo of the PLC program in progress as it runs the program and uses the simulator that we used with the program. This is the Productivity 2000 PLC. This is the power source, the CPU, the simulating program, and the outputs. So if we run the program, it starts tracking. These simulators will simulate a head. It cutting head being ran or not ran. So when it switches from off to on, it will data log. When this is switched, you can see the timer flip. This will symbolize the machine running. This one will simulate the machine being drained, and this will simulate the wheels being dressed. As these functions are called into action, they will be tracked in the data logger. The following graphic shows the data log imported from the PLC. It shows the cycle times of the various functions and also indicates which of the heads are operational for the cutting process. It provides a timestamp for each of the functions and will also tell you which of the functions are on or off at each specific time. So for long-term PLC solutions, we want to implement the PLC on each of the cutting machine. We're going to start with one machine and see how it works and then go from there. We also want to create a database to organize the data. This will be organized by function. The three functions we mentioned: cycle time, draining the vacuum, and redressing the wheels. It can be organized by the date, the time, and also the specific machine. And we can set up a query to show when a head will go down. In the future, we want to implement an HMI, which can track the data by the employee, which shift they're on, and which product they're running. And the ultimate goal of the PLC will be to replace the manual production sheets with the data log from the PLCs.
Using 2 years of machine production data provided by Rolf Glass, in addition to the data we collected on site, a data summary of the 6 primary cutting machines was formed to provide relevant minimums, maximums, and averages of cycle times and setup times. These numbers help to provide an idea of which machines were associated with high setup and cycle times. Also, the shop-wide average cycle time and setup time helped to provide a basis for the formation of a standard unit of production. This standard unit of production is a number that describes the amount of labor hours involved in one unit of production. After some numerical analysis, it was found that running the machine through one cycle is associated with 1.87 hours of setup, with 0.22 frequency of occurrence per shift, and 3.6 minutes of cycle time. And one piece of glass is associated with 0.28 hours of setup time with 0.22 frequency of occurrence per shift and 0.54 minutes of cycle time. Both standard production units help to provide the basis for the plant's production capability assessment as well as the production forecast. Due to the randomness of order arrivals, Rolf Glass does the majority of its production planning in a short timeline. The following chart helps to provide an idea of each machine's production capability given the fact that a certain number of setups must occur during a shift. This way, the production managers have a much better estimate of the quantity of pieces of glass that can be produced when filling an order. The following production capability chart was formed using the standard unit of production as well. All of the production numbers shown are values that could be attained if downtime is fully eliminated and machines are fully utilized. It was found that the plant can produce over 4 million pieces of glass if both of these things can be achieved. In 2015, the cutting department produced about 2.7 million pieces of glass. In order to achieve production levels more similar to the capability estimate, we suggest the following recommendations.
Using the calculated standard unit of production, we performed a short-term forecast of the labor hours needed to meet the predicted number of pieces that Rolf Glass will be producing in May and June of 2016. All of the pieces forecasted come directly from past Rolf Glass data. Each product was multiplied by the average cycle time per piece, and then summed to predict the total number of cycle time hours for each month. In addition to the cycle time, the total amount of setup time was added onto each month to get the overall labor hours needed. In order to reach these forecasted hours, we recommend reallocating human resources to satisfy those hours. Other recommendations our team has for Rolf Glass include the creation of standard operating procedures in order to reduce setup times, creating training manuals to lessen the learning curve for new employees, and implementing new incentive programs to encourage worker productivity.